All right, everybody. Thanks to Zach, I figured I would make a quick little video here showing you what your quick quiz is going to look like tomorrow. So here's the couple skills I'm requiring you to be able to do for tomorrow's quick quiz. So the first thing you have to be able to do is state the end behavior of a function. So here's a sample function. So the end behavior is coming from the first term. So whatever this first term is tells us what the end behavior is. So because this first term is negative and it has an odd degree exponent, I know my function is going to start up and end down. So if I was to type it in the calculator, I'm going to get something that looks like this. Now, the part of the question here is, do you know how to show the end behavior? So I'm going to say, as x gets smaller, the function, which is named f, is going to get bigger. As the x values get bigger, the function value, which is named f, is going to get smaller. That's what I'm expecting you to write for end behavior. Now, it's awesome if you remember the rule for the first term, but remember, you could always just type it in the calculator and just see what it looks like on the calculator. For the second part of tomorrow's quick quiz, that's a twisty word there. For the second part of the quick quiz tomorrow, you're going to be asked if the function that I gave you is odd, even, or neither. So to do that, you can look at the graph and see what kind of symmetry it has. If it has line symmetry, it's even. If it has point symmetry, meaning it's the same upside down, it's odd. If it has neither symmetry, well, this means it's neither. Now, the thing is, I'm not going to ask you to just look at the graph. I'm going to ask you to do it algebraically. So let's go over how to do that. So to do this algebraically, what we have to do is we have to put in negative x instead of x. So I'm going to have a negative 3 times negative x to the 7th power plus 5 times negative x to the 3rd power minus negative x. Now, when you plug in the negative x, if it has an even exponent, the term stays exactly the same. If it has an odd exponent, because of the odd nature of the exponent, it's going to change the sign of whatever it's attached to because it's going to stay negative. So what that tells me for this function I made up here is that the function negative x becomes positive 3x to the 7th because I'm going to have a double negative here, minus 5x to the 3rd plus x. Notice this function is not the same as the original function, meaning it's not even. To be odd, all of the terms have to have an opposite sign. So the first term is opposite in sign, the second term is opposite in sign, and the last term is opposite in sign. Therefore, this function is odd. Now, just identifying whether or not it's odd or even is not enough. I then have to say f of x, whoops, I don't know how I did that. F of x is odd because f of negative x is equal to negative f of x. Now, if you're watching this video, the function that you're going to get tomorrow is either going to be odd or even. I'm not going to give you one that's neither because that's not really testing that you know the sentences. So there are a couple sentences you should know. That is one of them. Now, the beauty of this is I could have like 3 or 4 different versions of the quiz all asking for the same skills. So just because your partner's quiz says even, yours might be odd. So just keep that in mind as you do the quiz tomorrow. So again, if you wanted to look at something to study for tomorrow, you should know the 4 different end behaviors from the lesson we did the other day. And Friday's lesson, determining if something is odd, even, or neither, algebraically, not just by the graph. Hopefully this video helped, and again, thanks Zach for this because I wouldn't have posted it unless he asked what was on the quick quiz tomorrow. Good luck studying, and I'll see you all tomorrow.